Day 83 of doing a LeetCode problem every day until I get a job. All right, guys, we're back again. Another day, another LeetCode problem. This time we're at day 83. We're making a little bit of progress, but we have a long way to go, guys. So I hope you're not losing any focus, losing any motivation, losing any discipline, because we're just getting started, guys, and we're just starting to have a little bit of fun and learn some new things. So before we get started, guys, don't forget, bring a mouse. Bring a mouse, bring a mouse, bring a mouse right over here, guys, and click that subscribe button for me. Then after you click that subscribe button, go ahead and smash that like button for me, guys. Then after you smash that like button, I need all of my bankers. I repeat, all of my bankers to the comment section and drop a comment in there so we could run this engagement up and we could help get this Swift community and this information about Swift to a broader audience so we could grow the Swift community as a whole, guys. But now, with that being said, I know why you're here. And today we have question number 1,318: minimum flips to make A or B equal to C. The difficulty level is medium, guys, but don't worry, you know how we do. We're gonna keep the solution as simple and easy to understand as possible, so we all can learn something today. And it's hard to learn something if you don't understand what it is that you're writing. So that's why we're going to keep it simple and easy to understand what it is that we're coding, so we all can learn something and walk away with this video with some knowledge that we didn't have before. Now, let's see what the question says. It says, given three positive numbers A, B, and C, return the minimum flips required in some bits of A and B to make A or B equal to C, bitwise OR operation. Flip operation consists of any single bit 1 to 0 or change the bit 0 to 1 in their binary representation. Okay, so let's look at the example to see what it is that they're asking for real. And guys, don't get confused, because yesterday we did the exclusive bitwise OR operation, but this is just the bitwise OR operation that we're going to be using today. Or we're going to use a little bit of both, but it's a little different, and I'll explain how when we get to the code. Well, actually, I can explain some of it right here at this example. So let's look at the example, right? So in the first example, we have the input A equals 2, B equals 6, and we're trying to get C to equal 5, or C does equal 5, and we need to count the number of flips to make that possible, right? So the output is 3 because we had to flip 3 different bits or integers to get the correct output, which would be C equals 5. So let's look at the explanation so we can see what it means. I'm gonna break it down a little bit more too. So it says after flips A equals 1, B equals 4, and C equals 5, such that A or B equals C. So let's see what they mean. So we started out, let's come over here so we can see. We started out with 2, which was like this. Excuse me. Then A was 2, B was 6, which looked like this, and we need C to look like this, right? So with the OR operations, as long as there is 1 that we're working with, is going to return 1. But right now, if you're looking, that would mean this should be a 1, and since there's no 1, that would mean this should be a 0. So it wouldn't be correct, right? Because this is, okay, so this is 0 and this is 1. So yeah, this should be, excuse me. So yeah, this should be 1, but this is 1 and this is 1. So this should be 1 as well. And this is 0 and this is 0. So this, since there's no 1s, this should be 0. So we need to figure out which of these bits we need to flip so that this would make sense with the OR, using the OR, bitwise OR, right? So that means we would have to come over here. We'd have to turn this into 0, 0, 1. So we would have to ignore this period right here. So we'd have to turn this 0 into a 1. So that'd be 1 flip. Then we'd have to turn this 1 into a 0. So that'd be a 2 flips. Then we come over here. And so we'd have to turn this, or yeah, then we'd have to turn this. I'll show you when it's done. So we would have to turn this 1, into a 0. So that would make a third flip. So really, for it to be correct, for it to be correct, for this to be correct, we would have to flip this into a 1, flip this 0 into a 1, which would be 1 flip. We would have to turn this 1 into a 0, which would be 2 flips. And we would have to turn this 1 into a 0, which would be a third flip. And that's why the output is 3, because we're working with the OR operator here, and as long as there's a 1, then it's going to output 1, right? And we wanted the output to be 5, which is this 1, 0, 1, right? So now we have 0 and we have a 1. That's going to come out to 1 because there's a 1 in it. Then we have a 0 and a 0. That's going to come out to 0 because there's no 1 in it. And then this is going to be a 1 and this is going to be a 0. That's going to come out to 1 because there's a 1 in that operation, right? So that means we had to flip these 2 bits right here, and we had to flip this bit right here, and all together we had 3 bits that we had to flip, right? So that's how the OR operator works. And when I say OR, I mean this operation as compared to this operation. We're not talking about this operation, because this operation, that's the one we went over yesterday, where it be if they're different. We're using, this right here, that's the exclusive OR operation. That's not what we're looking for. We're looking for this one right here, which is just OR, not the exclusive OR, which means if there is a 1, then it's going to come out to 1. If there's no 1, then it's going to come out to 0. And this is the one we're looking for, right? So let's see, and it'd be the same thing for example 2. So we have input A and B. We need that to equal C. We'd only have to flip 1 bit. And then we'd have example 3, we would have A equals 1, B equals 2, C equals 3. We wouldn't have to flip any bits. So now that we've got that figured out and we see what it is that they're asking, let's get into the code, guys. So guess what? And I got some good news, because guess what, guys? Today we have it. You guessed it. We got a one-liner, which kind of was like yesterday, but this one, hey, one-liner is a one-liner, and today we have a one-liner, and it goes something like this. So first we're going to open up the parentheses, then we're going to open up another parenthesis, and we're going to say A or B. And remember, guys, that's what we were just talking about earlier, where if there's a 1, then it's going to come out as a 1. If there's no 1, then it's going to come out as a 0. But then we're going to come over here, and this is the one we used yesterday. We're going to use the exclusive OR operation, and we're going to say C, right? Then we're going to come over here, and we're going to say non-zero bit count. And what that is going to do is that is going to count the number of 1s in that operation. So that's going to count all the 1s. Then we're going to say plus. We're going to come over here and we are going to open up the parentheses. We're going to say A and B and not C. So this operation right here is the bitwise not, just the not operation, right? So it's going to turn a 0 into 1 or 1 into 0, but that's like the not C. So it's A and B and not C, which is going to turn the 0s into 1s and the 1s into 0s. Then we're going to do the same thing, and we are going to say dot non-zero bit count. Bit count. And what that's going to do is going to count, what this right here is going to do is it's going to count all the 1s in A and B that are not 1s in C. So it's going to, or how many bits, it's going to count how many bits are 1s in A and B but not in C. And when you add these two together, it's going to return the minimum amount of numbers, or the minimum amount of flips that it takes, of bit flips that it takes to get the solution or the result answer that we're looking for, right? So when you add them together, it's going to count the minimum number of bit flips that we need, guys. And this is all she wrote. This is the one line of code, guys. So I hope you understand it. I hope it's you might have to go over it a few times so you can see what exactly it is that we're doing. But if you look at the past two videos, in the previous video we went over this operation, and in the video before that we went over this operation. So if you watch the last two videos before this, it should help you really internalize what's going on with this right here, guys. But that being said, let's run it and see how it runs. Fingers crossed, and it's accepted, guys. So let's submit it and see what happens after it's submitted. Let's see. Boom, 5 milliseconds, but it only beats 13.64% of users with Swift, guys. We could get these numbers up. It's a one-liner, but you can see it's not. It's all right, but it's a one-liner and it's easy to understand, and it gives you an example of different operations that you may come across when you're working with bits. So today we learned about two new operations that we haven't learned about before. We learned about this OR operation, and we learned about this NOT operation. If you want to learn about these operations, I encourage you to watch the previous two videos. The video before we learned about this operation, and the video before that we learned about the AND operation. So that'll help it all make sense for you guys. And we learned about this non-zero bit count today, guys. So that's something else we learned today. So I learned something today. I hope you guys did as well. And I will see you guys tomorrow for another day, another LeetCode problem. Peace.